So that's what happens here. All right, so that's good to know. All right, good, good. Okay, so now here, what do we also have? Well, okay, so we have this. And I just wrote two examples here. We have 1 is less than 2. That's, one example, right? Because 1 is strictly less than 2. We also have 0 less than or equal to 2. That's another possibility. That's okay. So we have those two quick examples. Nothing too fancy, I hope. Just want to make sure I'm still recording and the microphone's on. Good. Okay, beautiful. So that's what we have here. Okay, that's good. So we have that kind of inequality. And now using these symbols, actually, we can consider intervals, which I'll get to shortly. But first, I want to know, what questions do you have about this? If you have none, that's fine. But what questions do you have? Okay. We also have, now we can consider intervals. First, let's look at what's called the open interval. Suppose we have two numbers, a and b. Here we're going to assume a is smaller than b. Then the open interval from a to b, okay, it's denoted by this. I know it looks like an ordered pair or a point in the Cartesian plane, although we haven't gotten there yet, but you might have seen that before. This denotes an open interval. By definition, this is the set of all numbers between a and b, but you don't include a and b. That's really the important point here. You're not including a and you're not including b, neither one of them. Here, that's what this is doing, okay? So that's what this is doing. That's what, excuse me, what am I saying? This is actually how we graph this here, how we graph this open interval, okay? We mark off A and B on the number line. Since we're not including them, since we have these parentheses symbols here, we have open circles at A and at B. We have open circles at A and at B. That's what we have here. And we also draw this line segment connecting them just to show that all numbers between A and B are included. The open circles, that tells you don't include A and B. So as an example of that, 1, 2 here, this is the collection of all numbers between 1 and 2, but you don't include 1 and you don't include 2. So for instance, 1.5 would be in here. 1.9, 1.7, 1 and 2 are not included here. That's what we're saying here. Okay? All right. So again, open intervals, right? We have these open brackets here, open circles, right? We also have closed intervals. With a closed interval, okay, we have A and B, given two numbers now, okay? We have two numbers, A and B, where A is less than or equal to B now. So here we have A could equal B, or it's less than B. The closed interval is all the numbers between A and B, but here we're allowing A and B to be in here. So again, this is the collection of all numbers between A and B, but A and B, the endpoints, are in here. Visually, we can graph this set. That's what this is. Just like over here, we graphed the open interval, right? These open circles tell us that we don't include A and B. We don't include them. Here, however, we do include them. And how do we indicate that? We have these closed circles. We have these closed circles. Okay, that's what happens here. Closed circles. Okay, good, good. All right. So okay, so that's what's happening here. That's how we graph it. So this interval, for instance, 1, comma 2, these are all the numbers between 1 and 2, but we include 1 and we include 2. 1 and 2 are both included here. So like 1.1, 1.5, that's in here, but 1 and 2 are also in here. That's what these square brackets are supposed to indicate. You include those endpoints. So that's closed intervals. So we have open intervals here. We have closed intervals. We have also other intervals. We have what are called half-open intervals. You can call them half-closed. You'll see why. Basically here, you're including one endpoint and not the other. You're including one endpoint, but you're also not including the other. That's what this is indicating here. So here, because of the brackets, you can see that we would include A, we would not include B. So we would include A here, but we're not going to include B. These, again, are all numbers bigger than or equal to A and less than B. And this here is the graph of that interval. Closed circle at A, square bracket. Open circle at B, right? Open circle at B, that means we don't include B. Open bracket. That's what this is the drawing of. Okay. So that's half open interval. Some people might call it half closed. Whatever you call it, of the two, that's fine. So this, for instance, would be all numbers. This is half open, right? It's all the numbers between 1 and 2. You're including 1, but you're not including 2. The second example here is what you would get if you include the right endpoint, but you leave out the left endpoint. It's still half open. I mean, in this case, we're including 2. We're not including 1, though. So that's what happens here. So that's what happens here. Numbers between 1 and 2. Excuse me, but we're including 2. Okay. Are there any questions about this? Okay. All right. Let's suppose we wanted to make an interval where we include all numbers greater than 1. We're not including 1, though. So we want to include everything to the right of 1. How would we do that? Well, what we have seen so far is not going to help us. If we were to try something like 1 to 4, this is not going to help us, right? Because there's numbers greater than 5. Not to mention 4 itself is not in here. What about if we did something like this, 1 to 10? That's also not going to help us, right? Because 10 itself is not in here. Not only that, there are numbers bigger than 10, like 20, that are not included. That's not going to work either. So what do we do? Well, we need something that we haven't seen before, right? No interval of this form. That's what I'm trying to say up here. No interval of this form will help us where B is any number, because there's always numbers greater than B and B itself that we will not have, that we'll miss in the interval. That will not be in the interval. So again, we want to include everything to the right of 1, all numbers, bigger than 1, except 1. Not including 1, I mean. Nothing like this is going to work where B is any number. And this is why we have special notation as here. We have this new notation here. It looks like a figure 8. It's not a number, okay? It's not a number. Here, okay, this is not a number. Here, this figure 8-like symbol, it's just notation that's used to indicate you keep on going to the right along the number line, in the, how do I say it, the positive direction forever and ever. Even though technically there's no, there's no end of the line in the positive direction of the number line. There's no end of the line. There's no end to the number line, that is, on the right side. You could think of infinity as the end of it, though. Even though technically there is no end.